We now show how to translate English statements into logic. So for this, we'll do it by examples. So we're gonna, as usual, we need to always specify our domain. So here the domain will be the students in this class, and then it's good to have some predicates. Of course, that will depend on the statements that you're making, but for these statements, we'll be using the following predicates. So C of X will be X has a Clemson email. So again, the domain is the students in this class, and it's whether X has a Clemson email. E of XY will be X emailed Y. So student X emailed student Y. H of X will be X submitted homework 1. And P of X will be X is present today. Okay, so our goal is to write this in pure logic, with pure logic notation. So let's start with this example. So everyone here today has submitted homework 1. And there's, like we've saw before, there are many ways of writing the same logical thing. So there's not only one way to do these things, right? I'll just show the one that, at least to me, comes most naturally. But there are other correct options. For them to be correct, you would have to have them be logically equivalent, of course. So one way we can do, so everyone here today, so we want to talk about everyone. So I'll put a for every X, so that takes care of the everyone. And so everyone here today did the homework. So I need to check whether they are here today, and only if they are here today, I want to state that they did the homework. So an implication will take care of that. So for every X, if that person is present here today, so if P of X, then they did the homework. And so this is the equivalent to the English statement that we're writing, but using pure logic, right? So for every X, P of X implies H of X. So every student, if they are present today, then they did the homework. Okay, let's do another one. Let's do the second one. Someone emailed everyone else. Okay, so someone, it doesn't need to be everyone, it's just someone, and I don't know who. So this sounds to me like there exists an X, so there exists a someone, and he emailed everyone else. So I need to be able to talk about everyone else. So that means that for every, and now I need a different variable because I want to be talking about, it's not there exists X and then for every X, but we were talking about the exist X, it's for there exists an X such that for every Y, that person emailed them. Now, here we need to be very careful because we're saying that someone is emailing everyone else. So it's not the case. So one could think that you could say something like this. So there exists an X such that for every Y, X emailed Y. But this would also have the case where Y is equal to X, and so X emailed himself, right? Because X is also a student. So if we want to say that he emailed everyone else, we need to sort of check whether Y is someone else. So we say that if X is different than Y, then X emailed Y. So you see, here it's a bit different than saying that he emailed everyone. We're not saying that someone emailed everyone. We're saying that someone emailed everyone else, which does not include them. So there exists an X such that for every Y, if X is different than Y, then X emailed Y. Okay. Let's do a different one. So now the third one. 2 different students emailed each other. Okay, so now I'm going to need 2 different students. And it's not a for every on either of them. So there's going to be a student X and there's going to be a student Y. So these students, I want them to be different. and they need to email each other. So that means that I want X to email Y, and I want Y to email X. Because of course, if X emails Y, it doesn't necessarily mean that Y emailed X, so you have to have a separate statement for each one. So two different students, so there exists X and there exists a Y, and they emailed each other. Now they are different, right? So they're different students, so they have to be different. X emailed Y, and Y emailed X. Okay. And let's do the last one. And the last one, I'll show two equivalent forms. So not everyone submitted homework 1. So one way to do that is sometimes it's easier to just deal with the positive version. So if I wrote for every X, H of X, this means that everyone submitted homework 1. So then I can just say not this. So not for every X, H of X, right? So not for every X, it is the case that they submitted the homework. Now, another equivalent way to do this that you could think of is to say that, well, if not everyone submitted homework 1, then there exists someone who did not submit homework 1. So there exists an X such that homework 1 was not submitted, right? And here I can put the parentheses to make it clear. So there exists an X such that not homework of X. And these two are equivalent. And in a different video, we're actually going to see that you can always sort of transform negations of for all into existence of negations, right? So yeah, so for translating from English to logic, again, you want to always identify the domain, you want to identify the predicates, and then you do it by pieces, and there's more than one way to do it.